polymer. So in that we are seeing there polyethylene. So this is the last one example which we are seeing there. So this polyethylene which is also polymer, and also we are seeing there type of the polyethylene, that is a LDP, and another that is a EHDP. ELDP, that means low density polymer, and EHDP means high density polymer. So these polymer we are seeing in the last lecture. Also we are seeing their uses of these polymers. Now today from this lecture we are starting here next one, polymer, that is a Teflon. Teflon, which is the polytetrafluoroethylene. So this polytetrafluoroethylene, which is prepared by using a monomer, that is the tetrafluoroethene. So this is the structure of the tetrafluoro. These are the tetrafluoro ethene. So this is the ethene which is we are using there. So there is a polymerization which is takes place here in presence of the peroxide. So there is a formation of the Teflon. So this Teflon is another name, that is a polytetrafluoroethylene. Poly, N is the number, so that's why we are using there polytetrafluoroethylene. So this is the structure which is for the Teflon, and this is the polymer. We can successfully synthesize here by the polymerization or in presence of the peroxide. Now, what are the properties of the Teflon? Teflon, which is a tough, chemically inert, resists to the heat, and which is attacked by the corrosing reagents. So that is about the properties of the Teflon, which are the given there. So Teflon, which is having a carbon fluorine bond and which is difficult to the break, and which is remains unaffected by the corrosion alkali or organic solvents. Now, what are the uses of this Teflon? Teflon, which is used for the making of the non-stick cookwares, and also which are used for the oil seal or gasket. I think all of you know non-stick cookware. These are the very well known uh, these which is a very well known Teflon example, which is also used for the oil seals and also for the gaskets. Why? Because these are the non-sticky in nature, which is the corrosion free. There is no effect of the alkali or organic solvents. So that's why we are using there for the oil sealing. Next one, polymer, which is given there, that is a polyacryl nitrile. So this polyacryl nitrile, which is also polymer, which you are using there. So this polymer, how to prepare this polyacryl nitrile? Acryl acrylonitrile. So this is acrylonitrile we are using there. There is a polymerization takes place in presence of the peroxide. There is a formation of the polyacryl nitrile. So this is the structure of the polyacryl nitrile. So this polyacryl nitrile we are prepared here from the acryl nitrile polymerization process in presence of the peroxide. So this polyacryl nitrile, which is a resemble with the wool, and which is used for the making of the orals or acrylenes. These are the making for the dresses, or also which are the used for the making of the cloths also. So that is about the polyacryl nitrile. Next one, polyamide, which is given there. Now, what is a polyamide? So this is a polyamide which is given there. Polyamide generally, which is known as the nylon. I think a very well known example of the polymer, that is a nylon. So nylon, which is a synthetically prepared here. There are different type of the nylons which are the given there. Nylon in which there is a polyamide linkage which is present in the nylon. That means carbonine and NH, which are the bonded to the each other, and there is a formation of the nylon. Nylon 6,6 and nylon 6. These are the polymers which were prepared here by the different methods. In that nylon 6,6, how to prepare nylon 6,6? Nylon 6,6, which is prepared by the adipic acid. So this is a adipic acid structure which we are reacting with the hexamethylene diamine. So this is the hexamethylene diamine, adipic acid and hexamethylene diamine, which are the react with each other, and there is a formation of the nylon salt. So there is a nylon salt which is a formation here. So this nylon salt, which is intermediate shape, In the next step, we remove their n number of the water molecules. So this process, which is a happen at 553 kelvins and at high pressure. So there is the formation of the nylon 66. This is the structure of the nylon 66, which is the prepared there. So this is the nylon 66, which is a this nylon 66, which is a heavy in weight, which is having higher molar masses, which is given there 12,000 to the 50,000 units, which are the bonded to each other. So there is a linear condensation process, and which is having high tensile strain, and which is does not soak in the water, which is used for the making of the sheets, bristles of the brush, surgical structures, textile fabrics, etc. These are the uses of this nylon 66. दॅट मीन्स बऱ्याच जणांना माहीत असतील की नायलॉनचे रोप पण नसतात. हे रोप जे आहेत, देर इज नो अफेक्ट ऑफ द वॉटरमुळे काही त्याच्यावरती इफेक्ट होत नाही, त्याच्यामुळे वॉटर रेजिस्टन्स म्हटलं ते काय हरकत नसणार याच्याशी रिलेटेड. सो दिस नायलॉन 66, which is also polyamide polymer. Next one polymer which is given there, that is a nylon 6, which is a polymer which is prepared here. So this nylon 6, which is prepared from the E caprolactam, this is the E caprolactam structure, and we are heating in presence of the water at temperature that is a 533 to the 543 Kelvin. There is a formation of this nylon 6. So this is the structure of the nylon 6, which is a polymer. N number of the units which are the bonded to each other. So name of the nylon 6, which is given on the basis of the carbon 6 carbon atoms which are the present in the monomer. So in this structure you can observe there, or in this monomer, how many carbons are there? There are total 6 carbon. So that's why we are writing there nylon 6, because in the monomer, in this monomer, there are only 6 carbon which are the present here. So that's why name which is given there, which is having high tensile strength, luster nylon, which is having 6 fibers which are the used for the making of the tire, core, fabrics and ropes. Nylon 6 and nylon 6, these are the having near about similar uses which are the given there. Next one polymer, that is a polyester, which is prepared by using this ethylene glycol. This is the ethylene glycol structure. N is the n number of the ethylene glycol we are using there. We are reacting with the terephthalic acid. So this is the terephthalic acid which is given there in presence of the zinc acetate or antimonate trioxide catalyst, which we are using there, and temperature we are using there, that is a 420 to the 460. So there is a removal of the n number of the water molecules, and there is a formation of the terylene or uh, dacron. Okay, so this is about the preparation of the polyester. So this is a polyester which is prepared here. So there is a polyester, there is ester present, which is present there. So this is a polyester. So this terylene, which is having high melting point and which is a resistance to the water and chemicals also. So that's why these are the making for the wrinkles for or free fabrics by the blendings, or cotton, also wools, terylines also, which is used for the glass reinforcement materials, safety helmets. There are number of the uses which are the given there. These are also used for the making of the articles like the bottles, jams, packaging containers. So these are the containers which are the prepared here by using this polyester, which are the also kind of the polyester, which is a polycarbonate, and which is having higher melting, and which is having thermosetting resistance. So that is about the polyester, which is given there. Okay, polyester, how to prepare polyester. Starting ला आपण कसं प्रिपेअर करतोय बघा इथे. Polyethylene glycol which react with the terephthalic acid. So these are the two structure. There is a condensation process. याच्यातला water OH आणि हा H हा रिमूव्ह होतो. मीन्स काय होतं बघा याच्यामध्ये, this OH and H. Okay, OH and H removal takes place. There is a bonding. याच्यामध्ये बॉन्डिंग फॉर्म होत असतं. याच्यातला फक्त H आणि इथला OH हा रिमूव्ह होतो आणि त्याच्यावर रिप्लेस काय असणार इथे ऑक्सिजन आणि इथला हा ऑक्सिजन आणि हा कार्बन याच्यात बॉन्डिंग दाखवलेला आहे. So this process which occurs in presence of the catalyst, that is a zinc acetate or antimonate trioxide. Okay, temperature which is given there, that is a 420 to the 460 Kelvin. ह्या टेम्परेचरला काय होतं, वॉटर रिमूव्ह होतं आणि इथं काय असणार आहे, टेरलिन इथं फॉर्म होत असतं. ओके, टेरलिन और डॅक्रोन which is another name. टेरलिन which is having higher melting point which is resist to the chemicals, water. So that's why these are the used for the making bottles, jam bottles or package containing container जे आहेत हे कशापासून प्रिपेअर केले असतात, हे पॉलिस्टर जे आहेत त्याच्यापासून प्रिपेअर केले असतात. टेरलिन यूज केलं असतं त्याच्यामध्ये. जॅमच्या बॉटल असतील किंवा पाण्याच्या बॉटल असतात त्या सुद्धा काय केल्या असतात त्याच्या या टेरलिन पासून बऱ्याच वेळा प्रिपेअर केले जातात. ऑल्सो सेफ्टी हेल्मेट जे आहेत, हेल्मेट जे असतात त्याच्यामध्ये पण काय केलं असतं, हे टेरलिनचा यूज केलेला जातो. ओके, सो दॅट इज अबाउट द polyester, and this is the one of the example. Next one, that is phenyl phenol, which is a formaldehyde and which is related to the polymers which are given there. In that there is a one bakelite, which is a thermosetting polymer which is obtained by the phenol and formaldehyde. Phenol and formaldehyde which are the react with each other, and there is a formation of the, this is the synthetic polymers. So that is about the bakelite which is given there. Phenol and formaldehyde which are the react in presence of the acid, or also we can use their base as the catalyst. So there is a thermosetting, or there is a, this is the two-step reaction. Third stage, that is the shaping of the novels, putting in the appropriate molds. That means आपण काय करतो इथे जे आहेत आपण हीट केल्यानंतर काय असणार आहे, एक त्याला शेप प्रिपेअर येण्यासाठी आपण काय करतो, एक हाय टेम्परेचरला काय करतो याचा मोल्डिंग करत असतो, एक पर्टिक्युलर त्याला एक इथं हा शेप देत असतो. इन थर्ड स्टेप, दॅट इज थर्मोसेटिंग. मीन्स काय असणार, थर्मोसेटिंग ऑलरेडी मी सांगितलं. बऱ्याच वेळा बघा आपण, बऱ्याच वेळा काय होतं की तुम्हाला माहित आहे की प्लास्टिक आपण जर गरम केलं तर त्याला जसं पाहिजे तसा शेप देऊ शकतो आपण. सो शेप हा गरम असतानाच देतो आपण, आणि नंतर काय करतो ते कोल्ड झाल्यानंतर काय असणार ते, तो त्याचा शेप हा अचीव करत असतो. दॅट मीन्स विच आर द युजर फॉर द making of the articles also. So these are the can be used for the glass. Backlight which is used for the making of the articles like the telephone instruments, kitchenwares, electrical insulator. याच्यामध्ये हे बॅकलाइटचा यूज केलेला असतो. ओके, किचनवेअर्स मी आता सांगितलं की पर्टिक्युलर आपण त्याला हाय टेम्परेचरलाच काय करतो, शेप देत असतो, आणि नंतर काय करणार, त्याचा शेप अचीव झाला, कोल्ड झाल्यानंतर ते काय असतं, हार्ड कन्वर्ट होत असतं, विच इज नॉट फ्लेक्झिबल. ऑल्सो टेलिफोन इन्स्ट्रुमेंट जे असतील किंवा आपले जे मोबाईल आहेत त्याच्यामध्ये पण हे बॅकलाइटचा यूज केलं असतं. मोबाईलचे बॅक साईडचे कव्हर वगैरे जे आहेत हे काय केले असतात, हे याच्यापासून प्रिपेअर केले जातात. और इलेक्ट्रिकल इन्सुलेटर, इलेक्ट्रिकल इन्सुलेटर याच्यामध्ये पण काय केलं असतं, हे बॅकलाइटचा इथं यूज हा केलेला असतो. ओके, नेक्स्ट वन विच इज गिवन देअर, melamine formaldehyde polymer. So this is the decorating tabletop like the formica or plastic dinnerwares which are the made from the heating moisture resistance thermosetting plastic which is known as the melamine formaldehyde resin, and which is a reaction which is given in the next one diagram. Let's we check here, next page. Phenol which react with the formaldehyde, there is a formation of this our intermediate which is given there, ortho, para, meta. Okay, so these are the three possible products which are the formed here. Second stage आपण इथं ortho use करतो. Ortho there is a linkage takes place, there is a polymer formation here. Okay, this is the no-lag formation here, in no-lag which further connected to each other, and there is formation of the bakelite. Okay, so this bakelite also we are doing here preparation of the there is a cross linking of the melamine formaldehyde resistance इथे दाखवलेला इथे melamine formaldehyde याच्यामध्ये बॉन्डिंग फॉर्म होत असतं, आणि हे बॉन्डिंग इथे दाखवलेलं बघा, ह्या दोन्ही नायट्रोजनला काय केले, ते तिन्ही नायट्रोजन इथं हे बॉन्डिंग दाखवलेलं आहे, and there is a formation of the cross linked melamine formaldehyde resistance. Okay, and next one which is the reduced syllabus, आपण इथे जास्त कॉन्सन्ट्रेट याच्यावरती. So this is the next one point which is given there, that is also polymer Bona-S rubber. This Bona-S rubber which is the copolymer of the styrene and butadiene. So these styrene and butadiene which are react with each other, and there is a formation of the, this is the ESBR, that is the स्टेरिलीन ब्युटाडाइन रबर. स्टेरिलीन ब्युटाडाइन यूज केलं असं आपण त्याला काय म्हणतो, स्टेरिलीन ब्युटाडाइन रबर. अनदर नेम that is a Bonaies rubber. So this Bonaies rubber which is a polymer and which is prepared by the polymerization in presence of the sodium we are using there. So vulcanization with the sulfur we are using there vulcanization with the sulfur. So that's why which is the superior rubber we can prepare here. So this Bonaies rubber which is used for the making of the, I think तुमच्या समोरच लक्षात आलं असेल कशासाठी यूज केलेलं असतात हे, tire making, and also which are the used for the shoes. These are also shoes rubber which is from the Bonaies rubber, which is superior in nature and which is having mechanical strength, high mechanical strength, abrasive resistance, and which are the, because of that these are the used in the tire industry. Okay, so this is the next one polymer which is given there. Next one, neoprene. This is the neoprene which is a synthetic rubber which is prepared by the condensation of the polymer like the chloroprene, that is a 2-chloro-1,3-butadiene, and chloroprene, there is a polymerization in presence of the oxygen. So there is a vulcanization of the neoprene, and in presence of the magnesium oxide there is a formation of our final product. So this neoprene which is used for the making of the cables, also belt, a belt prepare करण्यासाठी पण याचा यूज केला असतो. Neoprene which are the particularly resist for the petroleum. These are the properties: vegetable oils, light as well as heat. यांचा रेजिस्टिव्ह प्रॉपर्टी त्याच्या पेट्रोलियमला रेजिस्ट करणारे vegetable oils, light as well as heat. So that's why these are the making for the hose pipe for the transportation of the gasoline, making of the gaskets. तुमचे पेट्रोल पंपवरचे जे पाईप जे असतात, पेट्रोल आपण जे गाडीमध्ये फिलअप करत असतो त्याचे पाईप, होज पाईप जे असतात हे कशापासून प्रिपेअर केले असतात, हे निओप्रीन. सो दीज आर द निओप्रीन बिकॉज ऑफ द दीज आर द रेज टू द पेट्रोलियम. पेट्रोलियमचा कुठलाही त्याच्यावरती इफेक्ट होत नाही, त्याच्यामुळे आपण ते यूज करत असतो. These are also used for the making of the insulating cables, jackets, belts, power transmitters, or conveyor belts. So that is about the uses of this neoprene. Okay, next one which is given there, viscous rayon. This is a viscous rayon which is semi-synthetic fiber which is regenerated in the cellulose. Cellulose which is the starting material we are using there, and which is in the form the wood pulp which is transported in the viscous rayon. Cellulose which is the linear polymer of the glucose, and which is having molecular formula which is given there, that is a 66H10O5. It is a modified resistance of the molecular formula. And cellulose which is having OH which is a functional part of this cellulose, which is used for the reaction with the viscous formation which is given in the figure. Okay, 6.7. Actually this figure which is in the next page, we are doing study here in how to prepare this viscous rayon. And this viscous rayon which is mixed with the dilute NaOH. Let's we check here how to preparation of this viscous rayon. So there is a preparation method which is given there, how to formation of the cellulose. Actually this part which is also from the reduced syllabus, but this is a simple process which is given there, how to prepare this cellulose textile. All these are the polymers which are given there. Okay, आपण polymer आहे कसं प्रिपेअर करायचं तर दिलेलं. Next one, that is a molar mass degree and polymerization which is given there. So this is about the information we can fill up here. आता याच्यामध्ये काय करायचं, नायलॉन 6 त्याचे रिपीटेड युनिट्स किती युनिट्स असतात त्याच्यामध्ये, नेम ऑफ द मोनोमर्स, कुठला मोनोमर इथे यूज केलेला असतो, फॉर्म्युला ऑफ द मोनोमर अँड युजेस. हे आपण सर्वांनी काय करायचं, तुमचा होमवर्क असणार. दिस इज युअर होमवर्क. ओके, व्हॉट इज युअर होमवर्क, दिस इज युअर होमवर्क. ओके, दिस इज युअर होमवर्क, सर्वांनी कंप्लीट करायचं हे, हाऊ टू. Next one point of this chapter, that is a biodegradable polymer which is given there. Biodegradable means biological degradable. Okay, जनरली आता बघा आपल्याकडचे जे पॉलिमर्स आहेत विच आर नॉट बायोलॉजिकल डिग्रेडेबल, खूपच लिमिटेड असे आहेत की ते बायोलॉजिकली डिग्रेडेबल आहेत. फॉर एक्झाम्पल तुम्ही मला सांगा, पॉलिथिलीन जे आहेत, आपल्या पोल्युशनचे किती प्रॉब्लेम आहेत आपण बघतोय तिथे. याचे काय आहेत, पॉल्युशन्स, एन्व्हायरमेंटल पोल्युशन क्रिएट होतं. पॉलिथिलीन असेल किंवा कुठलंही पॉलिमर यूज केलं ते काय बायोलॉजिकली डिग्रेडेबल नसतात. So that's why these are the remains behind in the environment, and because of that there is a pollution. So that's why there is a need of the biodegradable polymers. Biodegradable means which is the biologically degradable. Okay, so there are two type of the polymers which are given there. That is a PH BV. This is the polymer which is given there, which is the biodegradable polymer. How to prepare this BHBV? So this BHBV, which is a polymer which is prepared here. So what is the long form of the BHBV? That is the beta hydroxybutyrene co beta hydroxyvalerate. So this is a formula, or this is the long form of the BHBV. Okay. So how to prepare this BHBV? We are using the reactant, that is a beta hydroxybutyrate. So this is the structure of the beta hydroxybutyrate, which we are reacting with the n number of the beta hydroxyvaleric acid. So this is a beta hydroxyvaleric acid, n number of the beta hydroxybutyric acid, and n number of the beta hydroxyvaleric acid, which are the react with each other. There is a removal of the water removal, and there is a formation of the bonding in between them, and there is a formation of the BH BV. Okay, so this is a BH BV which is a we are prepared there. Next one point which is given there, that is the nylon 6,6. How to prepare this nylon 2,6,6 which is given there. Nylon 2,6,6 which is a polymer, copolymer copolymer of the two amine acids, which is the glycine, or which is the aminobutyric acid, which is a biodegradable polymer we are prepared here. So this is the biodegradable polymer PHBV, which is a biodegradable polymer, and this nylon 6 nylon 2, nylon 6, these are also biodegradable polymer, and which is having a similar property, similar their uses as compared to the synthetically prepared polymers. So that means BHBV and nylon 6, nylon 2, nylon 6, which is also biodegradable polymer, which is having a regular uses as like the synthetic polymers. This is the commercial importance of the polymers which are given there. Trade name which is given there, peroxy or acrylic glass, and monomer which is given there, that is a methylene macrolate, which is the structure which is given there, and polymer structure, and their application which are also given there, that is a lens, paints, security barriers, LCD screens, shatter resistance glasses. So these are the different important uses which are given there. Already aware in all these uses. आता हे ऍक्च्युअली तुमच्या होमवर्क मध्ये मी दिलेलं आहे. How do you do? You do homework of the all these important polymers. Okay. Homework today. Homework. So all of you complete all these important things which are given there. So in that, what do? You write down their trade name. Also, you are write down their monomer, name of the monomer we are using there for the preparation of the polymer. Next one, that is the structure of the monomer we are using here for the preparation of the polymer. Then after, you are writing their application of that polymer. So as like this way, you prepare a chart regarding to the polymers, their monomer which we are using there, their structure of the monomer, polymer structure also you are writing there, and then application of the polymer. So this is your today's homework.